superposition principle. Okay. In any medium, in any space, if more than two charges are present, okay, then how to calculate the force on any charge due to the other charges? Okay, so in that case we have to follow the superposition principle. What is that? The total force on a given charge is a vector sum of all the individual forces exerted by each of the other charges. Clear? That is, if here 1, 2, 3, 4 charges are present, we want to find out the charge on the charge particle, we want to find out the force on the charge particle 1 due to the charge 2, 3 and 4. Clear? Now, if we consider the individual mutual force between the 2 and 1, it should be along this. We know, using Coulomb's law, the force acts between the line joining between the point charges. So the force on 1 due to 2 is along this and is given by F12. Okay. Similarly, the force on 1 due to the charge 3 is along this and is given by F13 and so on. So the total force on the charge 1 is a vector sum of all the forces on 1. Clear? Now if a number of charges are there, then force on any particular charge due to the n number of charges is a vector sum of all the individual forces exerted by each of the other charges. Clear? Another one thing we should have to mention, the force between two charges remains unaffected due to the presence of the third charge. Okay, what does it mean? That is, look at the figure. That is, force between the charges 2 and 1 will remain unaffected in the because of presence of the charge 3 and 4. Similarly, force between 3 and 1, that is F13, will not be affected by the presence of the charge 2 and 4. Clear? Okay. Next we will know, that is, we'll compare between the Coulomb's law and Newton's law of gravitation. In class 11 we discussed about Newton's law of gravitation. It is given by F is equal to G into m1 m2 by r square. m1 m2 are the two particle mass separated by a distance r. And here the Coulomb's law, both are inverse square. If you notice, both are inverse square law. This is the similarity. Gravitational force is always attractive in nature, but in case of Coulomb's law, for unlike charges it is attractive, for like charges it is repulsive. Electrostatic force is much greater than the gravitational force. Okay, that is, if the two particles having masses m1 and m2 are separated by a distance r in a medium, then gravitational force between the two is experienced by the particles is given by this. Now if the two masses having charges q1, q2, if the two same masses having the charges q1, q2 separated by the same distance, then the electrostatic force is Fe, then Fe is much greater than Fg. Okay, this is because of this value of the constant. Okay, electrostatic constant is much greater than the universal gravitational constant. You know, this having value, but this 9 into 10 to the power 9 in SI. Okay. On the other hand, the value of capital G is 6.67 10 to the power minus 11. It's a huge difference. Okay. So electrostatic forces are much stronger than gravitational force. Okay. Now let us discuss about electric field. What is electric field? Electric field is defined as the space around the charge in which its influence can be felt by any other charged particle. That is, if we consider, here we consider a charge capital Q. Okay. In its surrounding region, that is the specified space in which if another charged particle placed, it will be affected because of this. Okay, that is, it will experience some force because of this. And this space is known as electric field. Okay. Now, what is the intensity of electric field? That is electric field vector E vector. Electric field vector E vector at a point in the space is defined as the ratio of electric force acting on a positive trace charge Q naught placed at that point to the trace charge. Okay, it is the ratio. Here, what is trace charge? I'll discuss later. So here, let us consider a charge capital Q, and here we put a trace charge Q naught. The electrostatic force is F between these two, and Q naught is trace charge. The ratio gives the intensity of electric field. Okay. Now, what is trace charge? Trace charge should have the property that it has very negligible value in comparison with this, so that it should not influence the field of this charge. That is, the value of Q naught is very small. Okay, mathematically we already has expressed here, that is E vector is equal to limit Q naught tends to 0 F vector by Q naught. Clear? Now the unit, SI unit of electric field, it is very clear to understand. Force is in Newton, Q naught, that is charge is Coulomb, so Newton per Coulomb. What is the dimensional formula? We can easily calculate F by Q, F mLT to the minus 2, ampere into time, it becomes mLT to the minus 3 ampere inverse. Now we'll find out electric field due to an isolated point charge. Okay, so to calculate, we considered here a coordinate XY axis, and the origin we put a positive capital Q charge particle, and we want to find out the intensity of electric field, suppose at a point P. So to find the electric field, here we put a trace charge Q naught, whose value is very small in comparison with this. Clear? So using Coulomb's law, the force between these two charges, capital Q and Q naught, which is also a positive, trace charge, its nature is positive. F vector is equal to K, which is electrostatic constant, Q into Q naught, R square R cap. As both are the same charges, the force on the Q naught should be repulsive. Okay. So this is the direction. Therefore E vector intensity of electric field according to the definition, limit q naught tends to 0, f by q naught, you just put this value. Okay, q naught cancels out here. Okay, and we get 1 by 4 pi epsilon 0. Putting the value of electrostatic constant, we get this. Okay, here we can graphically show how intensity of electric field varies with distance. Okay, so if we consider at the origin plus q positive charge is placed, a positive charge is placed, so it varies parabolically. It is very easy to understand the nature. Here it is E, it is in first degree, this is second degree R, so the nature is parabolic. So in this case, when E greater than 0, we'll get this nature. When E less than 0, it is very easy to understand, the nature should be like that. For negative charge, the nature of the curve is like that. For the determination of intensity electric field for some symmetric system, charge system, follow the next video. Thank you.